Today we're going to get into a two-part series on percents. In this video, I'll show you how to crack the tougher percentage word problems that you'll see on the SAT and the ACT. Okay, we're going to work through 10 percentage problems, starting with this one. Sam makes $15 an hour, then he gets an 8% raise. What is his new hourly wage? Well, it's not just 8% of $15, is it? That's the amount of the increase. But look, he gets his whole previous paycheck, the $15 an hour, plus he gets an additional 8%. So in other words, his new pay is going to be 100% of his old pay plus an additional 8%. So his new pay is going to be 108% of his old pay. Let's see, 108%. Let's convert that to a decimal. That's equal to 1.08. Because we move the decimal place 2 places to the left when we convert it to a decimal. We can rephrase this as, what is 108% of $15? What means in, is equals 108%. We're going to write this in its decimal form, which is 1.08. Of means times, and then we just copy the 15 down. Now we just need to multiply these out to find out in his new pay, which is 16.2. So his new pay is $16.20. We can add a 0 in there. So 108% of $15 is $16.20. Problem number 2, there are 1,000 people, 30% of them are happy. Of the happy people, 20% of them are tall. How many people are tall and happy? Well, let's see, we have 1,000 people. Let's write down what we're given. And of those, 30% are happy. So we could call this 30% of 1,000 people. And when we say of, what we mean is multiply. And if we have 30%, we can change that to a decimal by moving this decimal place 2 places. So it's 0.30. So 30% of 1,000 means 1,000 times 0.30. Of the happy people, in other words, of this group, 20% of them are tall. 20% of them are tall. So 20% of this, right? Again, we're going to convert that percent to a decimal, 0.20. And then multiply, because of means multiply. So 30% of 1,000 and 20% of that result equals in, the number that are both tall and happy. And when we multiply this out, we got 60 people. So in equals 60 people. Number 3, a basketball player made 63 out of 75 free throws. What percent is this? Well, this is not complicated. All we really need to do is divide. 63 divided by 75 will give us a percent. And that divides out to 84%. So this one is about as simple as it gets. Number 4, on a 120 question test, a student got 96 correct answers. What percent of the problems did the student work correctly? This one is just like the last one. So that he got 96 correct out of a total of 120 questions. So that's really just dividing. 96 divided by 120 to see what percentage this is. And that divides out to 80%. So he's going to get a B- on that test, it looks like. 80% correct. If 48% of the students in a college are female, and there are 2,400 female students. What's the total number of students in the college? Well, let's see, 48% of the students. Let's convert this to a decimal. 48% is 0.48, right? 0.48 of means times the students. Let's call this n. The students, we'll call that n, our variable, the total number of students. So 0.48 times n in a certain college are female. So that is the percentage of female students. 48% of the total students is, or equals, 2,400. 48% of the total students is 2,400. What is the total number of students? So to get that, we just need to divide both sides by 0.48 to isolate the n. So this cancels out, and we're going to get n equals 2,400 over 0.48, which is equal to 5,000. So there are 5,000 total students in the college. Number 6, if 65% of the animals in a shelter are dogs, and there are 180 dogs, what is the total number of animals in the shelter? So the total number of animals in the shelter, this is going to be in here. That's what we're trying to find. If 65% of the animals, this is in, 65% of n. What is 65% in a decimal? Well, that's 0.65. Of means times. The animals, this is in. 65% of the animals in the shelter are dogs, and there are 180 dogs. Well, 65% of n is equal to 180, isn't it? 65% of the animals is 180. What is the total number of animals? Well, it's solve for n. So we'll divide both sides by 0.65. This side cancels out, and 0.65. So our answer is 180 over 0.65, which is 277. That's the total number of animals in a shelter, 277. So this problem may be a little wordy. It's similar to the last problem. Write out what you're given. Figure out what you're trying to find, and then set up a variable for it. Number 7. Kayla earns $12.50 an hour, and her boss gives her a 6% raise. What is her new pay after the raise? Well, this one is very similar to number 1. So let's see, $12.50 an hour, 12.50, and they're asking us how much is her new pay after the raise. Well, it's 100% of that plus 6% more. So 100% of her old pay plus 6% equals 106% of her old pay. So her new pay will be 106% of her old pay. And let's see, we can convert this to a decimal by moving the decimal place 2 places, 1, 2. It's going to be 1.06. And take away the percent sign. So the decimal equivalent is 1.06 of 1250. In other words, times 1250. 1.06. Remember, of always means times. So her new pay is going to be 1.06 times 1250. And that multiplies out to 13.25. So her new pay is 13.25. Now, if they asked us for the increase, we could just subtract 13.25 minus 12.50, and we would get 75 cents. Or if they asked us for the increase, how much her raise was, well, it would be 6% of 12.50, right? 6% of 12.50 is 0.06 times 12.50, which would also give us 0.75, 75 cents. So, but it's asking us for the new pay. We want to make sure that we count her full amount of the old pay, 100%, plus 6% more. Okay, and problem number 8, Belinda buys a shirt at Walmart that is regularly priced at $45. If it is on sale for 20% off, how much does Belinda pay? Well, the way to look at this is, if it's 20% off, how much does she still have to pay? She pays 100% of the price of the shirt minus the discount, which is 20%. So she's going to pay, what's that, 100 minus 20? She still has to pay 80% of the regular price, right? She gets 20% off, so she still has to pay 80% of the regular price. So we're going to subtract her discount from 100, because 100 is the regular price. That's the full regular price, minus her discount. So she pays 80% of $45. So the question is asking us, how much is 80% of $45? Well, 80% is the same as 0.80. 80% of means times, and then 45 equals, and when we multiply this out, we get 36.00. So she's going to pay $36 after the discount, the 20% discount. Number 9, Marco finds a shirt at the Gap that is regularly priced at $52. Let's highlight that over here. $52. It's marked 25% off. It's on a clearance rack with a sign giving an additional 40% off the lowest marked price. So how much does he pay? Now we have 2 discounts. We're going to handle this the same way. So the first discount, he gets 25% off. So how much does he still have to pay? Well, he has to pay 100 minus 25. Because he pays 100%, this is the full price, right? Minus 25% is the discount amount. So he's going to pay 75% of the regular price of the shirt. That's how much his first discount is. That's not counting 40% yet. So his first discount gives him 25% off, so he still has to pay 75%. So what is 75% of 52? Well, 52 times 0.75. Okay, so that is applying his first discount. That's times. And then they're saying that he gets an additional 40% off the lowest marked price. Well, what is an additional 40% off? Well, let's see. That's 100 minus 40. So he would still pay 60% of the lowest marked price. So 40% off means that he still has to pay 60% of the lowest marked price. And let's see. So what we have to do is multiply this by the decimal equivalent of this. So what is 60% of the lowest marked price? This is the lowest marked price here we have, 52 times 0.75. And then he gets 40% off of that, so he has to pay 60% of that. So 60% of that is times 0.60. By the way, I kind of wrote this a little too close, but here's our solution right here. So now we just need to multiply these 3 numbers out. 52 times 0.75 times 0.60, and that's going to give us our answer, which is 23.40. So when we multiply that out, he's going to pay $23.40 for the shirt. That's his final discounted price after we applied the 25% discount and the 40% discount on top of that. Jennifer's best long jump distance increased by 10% from 1990 to 1991 and by 20% from 1991 to 1992. By what percent did her best long jump distance increase from 1990 to 1992? So we have 3 years here. We have a 1990, 1991, and 1992. let's see, she increased by 10% here and by 20% here. So you might be inclined to just say, well, gee, let's just add these together and say the answer is 30%. But we can't do that, and here's why. This 20% increase is not over the base year of 1990. It's over the previous year, 1991. So what we have to do is multiply 100% that she did in 1990 by the 10% increase, which is 110%, 1.10. And then we have to increase that again by 20%. So that's what she did here after the first year. What did she do after the second year? 20% more than that, right? 1.20. So when we multiply these out, we don't get 130%. We get 132%, or 1.32. In other words, the increase is if we convert this back to a percent, we get 132%. And if we take away the base year 100 that she started with, we get an increase of 32%. So she increased by 32%. Why? Again, this 20% increase in the second year is not 20% over the 1990s base distance. It's a 20% increase on what she was doing at the end of 1991. So we have to multiply 1.2 times 1.1 times 100. That gives us a 32% increase. So that's a little bit of a tricky question, but you have to think through it and make sure you're doing, this is basically called compounding increases, which is also used in calculating bank interest. I hope this video was helpful for you. If so, please click the like button and subscribe to my channel. I'm Joe James. Thanks for watching.